In this tutorial, we'll explore Codeium Windsurf, an AI-powered development environment designed to assist with coding tasks across various programming languages, including React Native, which we'll focus on here. Windsurf acts as an intelligent coding assistant, helping you write, edit, and understand your code more efficiently. While our examples will center around building and managing React Native projects, the tools and workflows you'll learn are adaptable to other languages and frameworks as well. We'll cover key features like Autocomplete for quick code suggestions, Supercomplete for multi-line completions, and Cascade, a conversational AI tool that helps with tasks like generating boilerplate code, debugging, and analyzing project structures. By the end of this tutorial, you'll have a clear understanding of how Windsurf fits into your development process, making tasks like navigation setup, UI implementation, and debugging smoother and more efficient. Windsurf is a standalone agentic IDE developed by Codeium that enhances productivity using AI-powered tools. It functions as an intelligent development partner by assisting in writing, editing, and understanding React Native projects through advanced context analysis. Unlike traditional coding environments, Windsurf does not merely suggest isolated snippets, but analyzes your React Native project holistically to provide meaningful and relevant suggestions. The application includes features such as Autocomplete for inline suggestions tailored to React Native code, Supercomplete for multi-line code completions based on the app's logic and context, Cascade for conversational interactions that generate and debug code, and a robust set of automation tools to handle repetitive tasks like boilerplate generation and refactoring. By indexing your project files locally, Windsurf can understand your dependencies, component structure, and navigation flows, ensuring every suggestion aligns with the specific requirements of React Native development. Windsurf offers 3 plans: Free, Pro, and Pro Ultimate. The free plan includes a one-time trial of 50 premium user prompts and 200 premium flow action credits, with access to the base model. This is sufficient for you to explore and experience the tool's capabilities. Once you run out of credits, you can upgrade to one of the paid tiers based on your needs. The Pro plan provides 500 premium user prompts and 1,500 premium model flow action credits. The Pro Ultimate plan offers unlimited premium user prompts and 3,000 premium model flow action credits. Both paid plans allow you to purchase additional credits and offer priority, unlimited access to the Cascade base model. Each message sent using a premium model consumes 1 prompt credit, and each tool call, such as create, analyze, search, modify, or terminal, uses 1 flow action credit. To begin using Windsurf, you need to download the application directly from the Codeium website. Open your browser and visit codeium.com. Click on the download button and select the version of Windsurf compatible with your operating system, whether macOS, Windows, or Linux. Once downloaded, follow the installation instructions specific to your system. After the installation is complete, launch Windsurf by opening the application from your system's application launcher. When you open Windsurf for the first time, you will have the option to import your settings from your previous IDE or start fresh. This step is particularly helpful if you've been using tools like VS Code or Cursor, as it saves time by carrying over your preferred environment setup, such as extensions, themes, and workspace layouts. For users new to coding or IDEs in general, starting fresh can be a good way to explore the default settings Windsurf provides, which are optimized for React Native development. Additionally, you have the option to add Windsurf to your system's path during setup. This step ensures you can use Windsurf directly from your command line or terminal, making project navigation and execution more seamless. Next, you'll choose your preferred key binding. The default is set to VS Code for familiarity, but you also have the option to choose Vim. If you are already comfortable with Vim's powerful keyboard-centric workflow, selecting it here can help boost productivity. New to Vim? Don't worry. VS Code's key binding is beginner-friendly and aligns with what most developers are familiar with. Additionally, you can customize your key bindings later in the settings to suit your workflow. After that, you'll set your theme type. You can choose between dark and light mode with styles like solarized, Tokyo Night, Synthwave, and Quiet Night. Dark mode themes like Tokyo Night and Synthwave are especially popular for reducing eye strain during long coding sessions, while light themes like solarized offer better visibility in brightly lit environments. Take a moment to try out each theme during setup. You might find that certain styles make code readability significantly easier based on your preferences. As the final step, you will be prompted to log in with your Codeium account. This login is essential for enabling Windsurf's AI-powered suggestions and assistance features, which rely on your account settings and preferences. If you do not have an account yet, you can sign up directly on the login page or at Codeium.com. You also have the option to sign up with your Google account, which is a faster way to get started. After opening your project's folder, Windsurf will initialize and begin indexing your React Native project files to provide context-aware suggestions. It automatically recognizes key files such as app.js, navigation configurations, component directories, and assets. This indexing process ensures that the AI suggestions are relevant to the structure and logic of your project. For example, it can suggest appropriate imports, autocomplete component names, and even offer recommendations for navigation setup or UI styling. After launching Windsurf, it is essential to get comfortable navigating the application interface to work efficiently on React Native projects. The main workspace consists of the central editor where you write and modify your React Native code, whether it is JavaScript or TypeScript. Inline suggestions appear as you type, seamlessly integrating into your workflow. On the left side of the window, you will find the Project Explorer, which displays your React Native project's folder structure, including directories for components, screens, assets, and navigation files. This makes it easy to navigate between parts of your application. On the right side, we have the Cascade panel. You can resize it to your preferred dimensions by simply dragging the handle. The Cascade Assistant is particularly powerful for developers because it enables you to interact with Windsurf conversationally. You can ask Cascade to generate boilerplate code for components, add TypeScript typings, or debug common issues such as incorrect styles or props. Cascade is Windsurf's AI-powered coding assistant designed to function as an intelligent collaborator throughout the development process. Cascade operates through two distinct modes, write mode and chat mode. Chat mode offers a conversational interface where you can engage Cascade to perform more complex tasks, troubleshoot issues, or explain code snippets. You can describe your problem or goal in natural language, and Cascade will respond intelligently. For example, if you need debugging assistance, you can paste the error message and relevant code snippet, and Cascade will analyze the issue, explain its root cause, and suggest a solution. Chat mode is also ideal for exploratory tasks like asking, "How do I implement React navigation with a tab bar?" It will respond with step-by-step code tailored to your project's context. In write mode, Cascade integrates directly into the editor to generate or refine code inline. You can trigger it by typing a command or prompt such as generate a React Native screen with a header and list items, and Cascade will inject the completed code directly into the file. Write mode is ideal for situations where you need immediate, context-aware code suggestions without switching focus away from your editor. Cascade allows you to choose from multiple AI models to tailor its performance based on your needs. Windsurf provides a balanced base model optimized for general-purpose coding tasks. If you require more advanced reasoning or code generation capabilities, you can switch to models like GPT-4o for high-accuracy completions or Claude Sonnet 3.5 for balanced multi-line suggestions and explanations. Selecting the right model depends on the complexity of your task and your performance requirements, as some models offer faster responses while others prioritize accuracy. A standout feature of Cascade is its image analysis capability. For React Native projects, you can upload screenshots or UI wireframes, and it will interpret the visual design to generate corresponding code. For example, you can provide a screenshot of a login screen design, and Cascade will generate the JSX structure, state logic, and inline styles needed to recreate it in React Native. It also includes a mention feature that allows you to reference files, functions, or other parts of the project during conversations. By mentioning a specific file, Cascade will analyze its content and provide tailored suggestions or explanations. This feature is particularly useful when working on larger projects where navigating between files manually can slow down development. One of Cascade's most powerful features is code generation. For example, we are currently prompting it to create a new screen for our app. Here is the prompt we are using. Create a profile screen that displays common information and follows a standard layout. Populate it with dummy data. Make it accessible by adding a new menu item in the navigation bar. Ensure it adheres to the app's style and layout. Windsurf's context awareness is a key feature that differentiates it from traditional development tools. The context engine allows it to analyze your entire React Native project, providing highly relevant suggestions and completions based on the structure, dependencies, and code logic. As we can see, the process begins with Windsurf analyzing the existing codebase structure and navigation setup. This ensures that any new additions will seamlessly integrate with the existing framework, maintaining the organization and consistency of the project. The ability to adapt to and respect your project's current setup reduces the risk of errors or misalignment when adding new features. Next, it reviews the existing style files to maintain consistency. This step is crucial for ensuring that any new components follow the same design language as the rest of your application. Whether it's adhering to a specific color palette, typography, or layout style, Windsurf ensures the new elements will look and feel like a natural extension of your app. Once it has gathered all the foundational knowledge, it presents a detailed plan for the task at hand. In this case, the plan involves creating a new profile screen and adding it to the navigation. This step is where you can notice the agentic workflow in action. Windsurf doesn't just dive into the code blindly, it carefully outlines the steps it will take. The first step in the plan is to create the profile screen. Once this step is completed, you can see the newly created profile screen in the Explorer on the left-hand side. Windsurf follows the established project structure, placing the file in the appropriate Screens folder, ensuring consistency and keeping your project well organized. After creating the profile screen, it moves on to update the app.tsx file to include the new screen. This ensures the new component is properly registered and accessible in your app's main flow. Without this step, the new screen wouldn't be available for navigation, so it's a critical part of the process. Next, it proceeds to update the navigation bar component. Here, it adds a profile menu item and implements the necessary logic for navigating to the new profile screen. Once all the steps are completed, Cascade displays and explains what it has done, highlighting the changes in the project files. This visual feedback is invaluable for understanding exactly what changes were made. New code is highlighted in green, while modified or removed code is marked in red. This color-coded approach makes it easy to quickly review and verify the updates. At this stage, you can see the newly created profile screen in action. Cascade even provides an interactive navigator in the main code area, allowing you to explore all the changes step by step. This tool is particularly useful for large updates, as it lets you focus on individual modifications without getting overwhelmed. We can now review the changes made to the app.tsx file to include the new profile screen. It ensures that all dependencies are properly imported and the necessary logic is implemented so that the new screen works seamlessly with the rest of the app. In the navigation bar component, Cascade not only added the new profile menu item, but also implemented the logic required for navigation. By adding the handle profile function, it ensures the menu item is fully functional, making it easy for users to access the profile screen. Finally, once you've reviewed all the changes, the tool offers the option to reject or accept them. You can approve the changes one by one, allowing for granular control over your project, or use the Cascade panel to accept or reject all changes at once. This flexibility is especially useful when working on complex features or collaborating with a team. When running the app, we can notice that there is an error. The error indicates that the app is using a profile placeholder PNG image that we do not have in the assets folder. This is a common issue during development, especially when new components rely on resources that haven't yet been added to the project. Identifying such missing dependencies is an important first step in ensuring the app runs as intended. Cascade is equally effective for debugging. If you encounter a runtime error or unexpected behavior, you can provide Cascade with the error message and a snippet of the problematic code. This feature is particularly valuable because it combines error analysis with actionable solutions, reducing the time developers spend troubleshooting. Instead of manually searching through documentation or forums for a fix, Cascade streamlines the debugging process. In this case, we can copy the error message displayed in the terminal and paste it into Cascade, asking it to fix the problem. Cascade's advanced debugging capabilities allow it to analyze the error contextually, considering the app's codebase and configuration. This ensures that the solutions it provides are specific and applicable to your project. It now understands the error and has found a solution. Instead of relying on the missing PNG file, it suggests using an icon from the Ionicons library, which is already integrated into the app. This approach is efficient because it leverages existing resources, avoiding the need to create or import new assets. Ionicons is a lightweight and versatile library, making it a great choice for quick fixes and consistent design. Once we accept Cascade's changes, the fixes are automatically applied to the code. We can then save the updated files and rerun the app to test it. This seamless workflow allows for rapid iteration, giving developers immediate feedback on whether the issue has been resolved. Now, when we run the app, the error is gone, and the application runs perfectly. This highlights Cascade's reliability, not just for building new features, but also for maintaining and improving existing functionality. When opening the menu, we can see the new menu item added for the profile page. The addition is smooth and integrates well with the rest of the UI, maintaining the visual and functional standards of the application. The profile screen itself is well designed, featuring a title at the top followed by a circular avatar placeholder. The placeholder dynamically displays the user's name and email address. This is achieved using text placeholders, which can later be replaced by actual user data fetched from the server. Such placeholders are essential during development as they provide a clear visual representation of what the final component will look like. Below the avatar, detailed vehicle information is presented. This includes the model, year, license plate, last service date, mileage, and more. The information is laid out in a clean and minimalist design, adhering to our app's established style guide. The logical grouping of data improves readability, ensuring users can quickly find what they're looking for without feeling overwhelmed by clutter. Windsurf also has a powerful feature called Command, which can be activated using the hotkey Command +I. This feature is designed to make your workflow more intuitive and efficient by enabling you to perform tasks directly from the terminal or editor without needing to recall exact syntax. Whether you're running a command line operation or modifying code, Command adapts to your needs, making it a valuable tool for both beginners and experienced developers. In the terminal, Command allows you to input queries in natural language. For example, instead of typing a complex command to install a package or run a script, you can simply describe what you want, and Command will generate the appropriate syntax for you. This eliminates the need to constantly refer to documentation, saving time and reducing the likelihood of errors. Here we asked it to launch Expo. In the editor, Command works contextually based on your actions. If you highlight a section of code before invoking Command, the AI will edit only the lines you've selected. This targeted approach is incredibly useful when you want to make specific adjustments without affecting the rest of your code. If no code is highlighted, Command generates code at your cursor's location. This makes it a versatile tool for adding new features or writing boilerplate code, all without interrupting your workflow. In this example, we're asking it to change the dummy data in our code. Notice how the process is seamless. The old code is highlighted in red while the new code is highlighted in green. This color-coded feedback ensures that you can easily identify what has been modified, providing clarity and confidence in the changes being made. Once the changes are saved, we can see the updates reflected immediately in our simulator. This demonstrates how user profiles can be dynamically displayed. In this scenario, we're working with placeholder data, but in a real-world application, this information would typically be fetched from a database or API. The ability to quickly test changes with dummy data is invaluable during the development phase, as it allows for rapid iteration and prototyping. You can also undo any changes made by command simply by pressing Command+Z. This instantly reverts the code to its previous state, making it easy to experiment without fear of losing your original work. Whether you're testing new functionality or exploring different approaches to a problem, this undo feature is a safety net that encourages creativity and efficiency. Additionally, Command's integration into the editor and terminal makes it a versatile tool for quick modifications. For instance, if you make a small mistake or decide to tweak a recent change, you don't have to rely on version control or commit history. You can simply undo and revise on the spot. When examining our profile screen, we notice that it is missing an important part, the button to navigate back to the previous screen. Navigation buttons are a key element in ensuring a seamless user experience, particularly for apps with multiple layers of screens. Without them, users may feel stranded, unable to return to previous sections. Let's ask Cascade to implement the back button for us, making sure it matches the one used in the temperature history screen. This demonstrates Cascade's ability to reuse patterns and styles from existing components, ensuring consistency across the app. With a simple natural language request, we ask it to replicate the back button functionality and design. Now we can see that Cascade first checked how the back button was implemented in the temperature history screen. This step highlights Cascade's ability to analyze your project structure and understand the context of existing components. It doesn't just guess. It references the relevant code to ensure the new implementation aligns with your app's logic and style. After analyzing the temperature history screen, it updated the profile screen to include this button. Cascade even provided us with the exact steps it took to fulfill this request. This transparency is incredibly valuable, especially for developers who want to understand the reasoning behind the changes and learn from the AI's process. By breaking down the steps, Cascade ensures that you remain in control of your project and can confidently approve or reject the modifications. The new code is highlighted for easier reading, with changes clearly marked in green. Once we've reviewed the changes and are satisfied, we can proceed to accept them. Now, we see that the back button has been added to the profile screen. If we compare it to the one in the temperature history screen, we find that it is identical in both design and functionality, just as we requested. This ensures a consistent user experience across different screens, maintaining a professional and polished look throughout the app. With the back button complete, another inconsistency catches our attention. The profile title doesn't match the style of the title in the temperature history screen. Consistency in typography and design elements is crucial for creating an app that feels cohesive and user-friendly. Visual mismatches, even small ones, can detract from the overall quality of the application. Once again, we turn to Cascade for help. We simply ask it to adjust the profile title to match the style of the temperature history screen. This process demonstrates how natural language commands and specific requests can unlock the full potential of AI tools. By providing additional details if needed, such as font size, weight, or color, you can achieve precise results tailored to your app's design language. After accepting the changes and saving the file, we can check the result. The typography is now completely consistent with the temperature history screen, using the same sizes, weights, colors, and font families throughout the interface. This demonstrates Cascade's ability to not only follow instructions, but also implement them with precision down to the smallest detail. And just like that, we have built a completely new screen with just 4 prompts. This demonstrates how you can accelerate your development process using this tool. With this workflow, you can fully leverage Windsurf's agentic AI. Autocomplete and Supercomplete are Windsurf's AI-powered tools that make coding faster, more accurate, and less repetitive. Autocomplete provides inline code suggestions as you type, offering completions based on the current file, imported libraries, and indexed project context. For React Native development, Autocomplete intelligently predicts component names, props, hooks, and style properties. Supercomplete takes Autocomplete a step further by offering multi-line code completions that align with your intent, even if you are working away from the cursor. By combining context awareness, Cascade, and advanced autocomplete tools, Windsurf transforms React Native development into a smoother, faster, and more intuitive process. Whether you are generating new code, debugging existing issues, or refactoring complex components, these functionalities allow you to focus on building high-quality applications with minimal friction. Windsurf's image feature allows you to include images directly in your prompts, making Cascade even smarter with its suggestions. You can add screenshots of your Figma designs, wireframes, or other visual references, and Cascade will use them as context to generate more accurate and relevant outputs. This is especially helpful when translating design ideas into code or refining UI components. It's a great way to bridge the gap between visuals and functionality seamlessly. We will use this feature with these login and sign-up cards from Design Code UI. These pre-designed cards are a great starting point because they already follow a clean and professional design structure. We will start with the login card to test the image feature in Cascade. The login card is a foundational element in most applications, serving as the entry point for users to access their accounts. Click on the image icon and choose your image. Prompt the AI with what you need. We are asking it to create a new page called Login and add another menu item to navigate to this page. On the Login page, create a login card with the provided image. The clarity of your prompt is crucial here. The AI operates based on the instructions you give, so being specific ensures that it produces the result you want. In this case, our request is broken down into 3 clear tasks. First, create a new page named Login. Second, add a new menu item so users can navigate to this page easily. And third, populate the new page with a login card that uses the selected image. This structured approach helps the AI understand the task and execute each step methodically. Pay attention to how the AI is handling your request and what it is doing. We can see that it starts to analyze the project as usual. As the AI begins analyzing the project, it looks at the overall architecture, including existing pages, navigation paths, and file structures. This step is crucial because it ensures the new additions, such as the login page and navigation updates, align with the existing framework. Once the analysis is complete, the AI proceeds to create the login page. It uses the image as a reference point and integrates it into the design in a way that complements the layout. After creating the page, the AI moves on to one of the most critical aspects: navigation. It updates the apps.tsx file to ensure the new page is registered correctly in the project's routing system. Then, it modifies the navigation bar component to add a new menu item labeled Login. This ensures users can access the page seamlessly through the app's main navigation. Once the AI has completed its tasks, it presents the code for review. This is an opportunity to inspect the implementation, check for any potential issues, and ensure the code adheres to your project standards. After reviewing the code, we can accept the AI's changes. This step finalizes the integration of the new login page into the project. Once accepted, we can run the application and see the page in action. This is the moment where everything comes together, and we can fully appreciate the efficiency of the AI's assistance. Opening the app and navigating to the menu, we immediately notice the new Login menu item. It's seamlessly integrated alongside the existing options. Clicking on it takes us directly to the login page, confirming that the navigation changes were implemented correctly. The login card looks polished and functional, and the layout is structured well enough to be usable right away. Achieving this level of quality with just one prompt is remarkable and demonstrates the strength of this tool in handling both design and implementation tasks. Of course, it needs some fine-tuning. When compared to the original, it's pretty close. We can adjust the layout of the button and refine some overall styles if needed, but this provides a solid starting point. Starting from an AI-generated component rather than building it from scratch saves a significant amount of time and effort. The ability to add functional, visually appealing components to a project with just a few prompts is a massive advantage. This feature highlights how AI tools are reshaping the way we build and design applications, making the process faster, smarter, and more accessible to teams of all sizes. In the code, we can see that it used states for the email, password, and the Remember Me checkbox. This means the AI didn't just create static UI elements, but actually set up dynamic state variables for these key components. By using states, the AI ensures that the email and password fields are able to capture and store user input, and the checkbox accurately reflects whether the user has opted to be remembered on their next login. This approach follows standard best practices in modern development frameworks, ensuring data is managed efficiently and updates correctly when user interactions occur. Additionally, using state management simplifies the process of accessing these values later, such as when submitting the form or validating user credentials. It also prepared the functions for the Sign-In, Apple Sign-In, and Google Sign-In buttons. These functions serve as hooks for further customization, allowing developers to add authentication logic or API calls as needed. For instance, the Sign-In button might later trigger a function to validate the email and password, while the Apple and Google Sign-In buttons could be connected to their respective OAuth services. This shows that it understood the elements, and it's not just building a UI design, but knows how to integrate functionalities. The AI isn't simply placing components on the screen, it's building a bridge between the user interface and the underlying application logic. This level of understanding demonstrates that the IT can interpret the purpose behind each UI element and prepare it for real-world use. It's not just creating a visually appealing login page, it's setting up an interactive, functional system that can be built upon. This distinction is critical because it shows the AI isn't just working on the surface level, but is also aware of how these elements will operate within the broader application architecture. We can interact with the elements in the app. The email and password fields are real text inputs. We can type in the field. This means the text fields aren't static placeholders. They're actual interactive components designed to accept user input. We can also interact with the checkbox to display a check mark. The checkbox isn't just a static icon, it's fully functional. When clicked, it toggles its state between checked and unchecked, visually displaying a check mark to indicate its current state. The state of the checkbox can be easily accessed later to remember the user. When we click on any of the buttons, whether it's the Sign-In, Apple Sign-In, or Google Sign-In, the corresponding functions trigger successfully. Right now, these functions are configured to print a simple log message in the console, but they can easily be expanded to include logic for authentication, error handling, or API communication. The fact that these buttons are already wired up with functional callbacks indicates that the AI understands the importance of making UI components fully interactive from the start. Overall, what we see here is more than just a static UI. It's a functional, interactive login system with dynamic states, prepared functions, and seamless interactivity across its core components. This sets a strong foundation for further customization and refinement, while saving significant development time up front. The login page is really nice, but it is missing an important element: a way to navigate out of the screen. While the page is functional and visually appealing, users currently have no way to exit the login screen or return to a previous section of the app. Navigation is a fundamental part of user experience, ensuring that users can move seamlessly between different sections without feeling stuck or restricted. Without a navigation option, even a well-designed page can feel incomplete. For this, we will ask it to add the navigation bar like in the mode control screen, but the back button will navigate to the mode control screen. The navigation bar provides a consistent structure for moving between different screens in the app. By referencing the mode control screen, we ensure that the navigation bar matches the style and behavior already established in the project. By now, you should be familiar with the process. Prompt the Cascade tool, let it analyze and make the changes for you. At this point, using Cascade has likely become second nature. Then, once it is done, review the code and if satisfied, apply the changes. Now, let's test it in the app. We immediately notice the familiar navigation bar, and when pressing on the back button, it takes us to the mode control screen, just like we asked. Pressing the back button triggers the expected behavior, navigating us directly to the mode control screen. This smooth transition confirms that Cascade successfully implemented both the visual and functional aspects of the navigation bar. Let's now try the menu. Here, we see the menu is working, but it is showing behind the login card. This issue is a layering problem, where the z-index or stacking order of the elements causes the menu to render behind the login card. While the functionality of the menu is intact, the visual issue prevents users from interacting with it as intended. These small quirks are common in UI development, especially when introducing new components or modifying existing layouts. Fortunately, addressing such issues is straightforward. If something is not behaving like you want, simply re-prompt Cascade to correct it. One of the best aspects of working with Cascade is the iterative nature of the tool. If a specific behavior isn't aligned with your expectations, like the menu rendering issue, you can simply refine your prompt. We are now telling it that when opening the menu on the login screen, the login card should be behind the menu. The goal here is to ensure that the menu behaves consistently across different screens, providing a seamless and predictable user experience. Consistency across screens is crucial for creating a polished app experience. After Cascade processes the instructions and generates the necessary code changes, we move on to testing. The visual and functional alignment between screens confirms that the adjustments were successful. The menu smoothly slides into view, the opacity overlay dims the background appropriately, and the login card stays hidden behind the menu layer. This consistency enhances the overall professionalism and usability of the app. Testing further, we verify that navigation remains fully functional even after interacting with the menu. The menu can be closed without issue, and clicking on navigation items takes us seamlessly to other pages. This ensures that the changes made to the menu have not unintentionally disrupted other app functionalities. Right now, the close button of the pages goes back to the previous screen, but you can easily change it to a different behavior. For example, it could navigate to the mode control screen. The behavior of the close button is flexible and can be adjusted to match specific requirements. Using these techniques, make sure to customize and adapt to your own project. The true power of these tools lies in their adaptability. Let's now test the image capability of Windsurf by creating another screen. This time, we'll focus on implementing the sign-up card. To ensure clarity and precision, we'll provide specific instructions for how this screen should behave and interact with the existing login page. We'll prompt it to create a new page named Sign Up, styled similarly to the login page but featuring a sign-up card designed according to the provided image. Additionally, we'll include navigation links at the bottom of both pages for smooth user flow. On the login page, there will be text at the bottom saying, "Don't have an account? Create an account here," with "Create an account here," functioning as a clickable link that directs users to the sign-up page. Similarly, on the sign-up page, we'll have text saying, "Already have an account? Log in here," with "Login here" serving as a link back to the login page. This approach not only tests Windsurf's ability to interpret visual input, but also its capability to handle navigation logic between connected screens. After the prompt is processed and the changes are applied, we'll move on to reviewing the generated code. The initial inspection ensures that the sign-up page mirrors the login page in structure and style while still maintaining its own unique sign-up card. Once we confirm that the links and navigation elements are correctly implemented, we'll proceed to accept the changes and run the app to see the results live. Upon launching the app, we notice the bottom text on the login page is present exactly as described. The phrase, "Don't have an account, create an account here," appears cleanly at the bottom, and the link is functional. Clicking on it smoothly navigates us to the new sign-up page, where we find the sign-up card correctly displayed with all expected functionalities. Just like the login page, the sign-up card includes email and password fields, as well as functional buttons ready to handle user interactions. At the bottom of the sign-up page, we also see the text saying, "Already have an account? Log in here." The link behaves correctly, taking us back to the login page without any delays or errors. This demonstrates that Windsurf can handle both visual instructions from the provided image and navigation logic defined in the prompt simultaneously. However, while testing the back button, we notice an issue. Pressing the back button on the sign-up page takes us to the driving performance screen instead of returning to the mode control screen. This indicates that the sign-up page was not correctly configured in the navigation bar and is currently inheriting the same behavior as the mode control screen. Although the main navigation links work as expected, the back button behavior requires adjustment. This isn't a major problem, though. Just like before, we can address this by refining our instructions. We'll simply ask it to adjust the back button in the navigation bar of the sign-up screen so that it navigates directly to the mode control screen. With this clear instruction, Windsurf processes the request and applies the necessary changes to the navigation bar configuration. Upon reviewing the updated code, we can see the specific fix made to the navigation bar. When testing the app again, the back button on the sign-up screen now functions exactly as expected. Pressing it seamlessly takes us to the mode control screen, resolving the previous issue. This small but crucial adjustment brings clarity and consistency to the navigation flow, making the user experience smoother. Additionally, the menu remains fully functional. It opens without glitches, displays correctly over the sign-up card, and behaves exactly as intended. Navigating between different screens using the menu feels fluid, and no unexpected behaviors occur during transitions. With these implementations complete, it's clear that you now understand the workflow and capabilities of Windsurf. The iterative process of prompting, reviewing, testing, and refining highlights the tool's efficiency and adaptability. This agentic approach showcases how AI-powered tools can handle both broad tasks and precise corrections with ease. As AI continues to evolve rapidly, integrating it into your workflows is no longer optional, it's essential. If you found this tutorial helpful, let us know by giving it a like or leaving a comment. Thank you for watching and see you in the next tutorial.